Hi, hello, good evening, guys. Welcome back to my YouTube channel, like your Mathsbuddy. I hope you people have watched my all of the previous videos. As we know that we are in the third chapter of the class 12 matrices of the NCERT syllabus. Okay, we have completed till example 21st of this chapter, and now we are in this going to do the we'll start from symmetric and skew symmetric matrices. In the previous videos, we have done. Started with the transpose of the matrix, and now we are like the skew and symmetric and skew symmetric are like the other part of the transpose of this matrix. Okay, yes, let us start with this discussion. Yes, since I have uploaded my last video week back, and I hope you people are watching that, and some people are enjoying your holidays. Even due to some festival also, I also didn't uploaded any kind of videos, but as I given a commitment for you people, again you will going to see my back-to-back videos on my YouTube channel. Okay. If you have any kind of doubts, queries, means you just ping me in the WhatsApp Telegram channel, which is already mentioned in the bio of my YouTube channel, or else in the YouTube comment box. Okay, okay, guys. Let us start. What do you mean by symmetric and skew symmetric? 1 minute. Let me change the color. Yeah, symmetric and skew symmetric matrices. Let me show one example first, and later on we will discuss what do you mean by symmetric and what do you mean by skew symmetric. Okay. A is equal to a square matrix can be any number. Hmm. The condition for the symmetric matrix is it should be a square matrix. Okay, and non-diagonal elements should be same. Like, what do you mean? But see, this one, two, and three is a non-diagonal element. If you consider apart from this one, two, three, the other corresponding elements must be same. Like how it is. See, you can see here 4 and this 4 is same. This 5 and this 5 corresponding elements are same. This 6 and this 6 is same. See, if you consider when you are folding one triangle or folding one page, if you are folding this uh, rectangular page means this should be the scribe, but this fourth other corner should be equal. In the similar case, when you fold this matrix, I cannot show my hand gesture, but you just assume that if you close this, if you fold this matrix by using 1, 2, 3 in the diagonal elements, the 4, 4 and 5, 5 and the 6, 6 should be your corresponding elements. And all these three upper corresponding elements and three non-diagonal elements must be equal. Then it is a symmetric matrix. For symmetric matrix, there is a two condition. First one, it's a square. It should be a square matrix. Second one, the non-diagonal elements must be same. Okay. Yeah. Hmm. What do you mean by skew symmetric? What do you mean by skew symmetric? I will use the same thing, but in the skew symmetrics, this no diagonal elements must be zero, and non-diagonal elements must be. You can say this 4, 5, 6, and here this will become the negative sums. Okay. Yeah. This thing will become skew symmetric. Here also there are two conditions. First one is it should be a square matrix. I hope you people know what is square matrix. Square matrix in the itself, the number of rows are equal to the number of columns. Okay. And one more thing is diagonal elements must be zero. must be 0 and in the opposite direction. Okay, this, if you still see that, if you are just holding this diagonal elements on your hand, you folding the this matrix, this 4 and this 4 will be same, but on it should be in the, it should have the opposite order in the sense, if it is positive means here it can be negative, if it is positive means here it can be negative. Even though, like, I will show one more example for this one. So one for skew symmetric, I will give the same kind of example. 0, it is 4, it will be minus 5, this is plus 6, minus 4, 5, here 0, and here it is minus 6, and again here it is 0. So you can observe here, the first condition is it is a skew symmetric because our rows are equal to the columns, it is a scalar matrix, and second condition is diagonal elements are 0. Okay, and other one is these are having opposite signs. You can observe this, 4 plus 4 here, minus 4 here, plus 5 here, minus 5 here, plus 6 here, minus 6 here. This is a square symmetric, a skew symmetric. That is a symmetric, and this is a square symmetric. Let us see the example, the definition, and you will come to know what actually it is. See, definition for a square symmetric, A is equal to Aij is said to be a symmetric if A dash is equal to A. A dash is equal to A. What is this A dash is equal to A? I will say wait for 2 minutes. That is Aij is equal to Aji for all possible values of I and J. What do you mean by Aij and Aji? They have given one thing, A equal to A dash. And if you know, if you consider A here, and I will take the same thing as an A dash, if you know this, A dash in the sense A to the power T. A to the power T is a transpose matrix of A. Means you need to change from order to rows to column, columns to row. Okay, let us begin with this first column. I will write in row 1. This is A dash 1, 4, 5. And second one 4, 2, 6. And third one 5, 6, 3. Still you can see there the 1, 2, 3, the elements will never going to change, the diagonal elements are always be the same. So whatever the elements will be changed is like a non-diagonal elements. You can see this 4, 5, 6. These non-diagonal elements and these non-diagonal elements both are same. Okay, that's why they have written A is equal to A dash. In the symmetrics, A and A dash is always a equal term. Okay. You can observe here as well. I will write A dash. A dash is equal to, I will start from here. Where it is here. Root 3, 2, 3. The second one is 2 minus 1.5. Yeah, 2 minus 1.5 minus it is. And third one is, and this third one is 3 minus 1, 1. It is 1.5. You can see here still this diagonal elements is there, and non-diagonal elements must be same, 2, 3 minus 1, 2, 3 minus 1. In skew symmetrics, the sign will be changing, but in only symmetric, even the sign will also be having the same thing. Okay. So you can observe here it is a minus 1, and here also it is a minus 1. Okay, the non-diagonal elements, especially for, let us go for definition number 2. What do you mean by skew symmetric? It is a square matrix here. As we consider square matrix is said to be a skew symmetric if A dash is equal to, or the transpose of A is equal to minus A. That is Aji is equal to minus of Aij. I will say this, wait for 2 minutes. For all possible value of I and J. Now, if we put I equal to J, we have Aii minus Aii. Therefore, 2Ai is equal to 0. AI is equal to 0 for all i's. This means that all the diagonal elements of a skew matrix are 0. You know that it is a square matrix. You people know that the skew matrix or the diagonal elements must be 0. What do you mean by this a dash and 2ai? See, they have written that if I is equal to j means row is equal to column. However, it is since it is a scalar matrix, rows should be equal to the columns. Okay, but this condition is satisfied. So they have replaced this j with the I. It will become 2ai. They have written this ai. Okay, so they have converted this ai plus they have shifted this with here, and this will become ai equal to 0, and they have mentioned as they 2aii equal to 0. We transfer this nominator, if it will become denominator, again still it is a 0 by anything is always a 0. They have solved this here. Okay, why this is a dash is equal to uh, what is this minus a, I will say is also very simple thing. Mhm. You consider here a, I will write transpose of a. You start from here 0 4 5 minus 4 0 6 minus 5 minus 6 0. You say the diagonal elements, however, they will be the same, but the non-diagonal elements they have interchanged their place. Okay, that is the reason when you are doing a minus b, you will come to know what is the result. So that is the reason they are saying that if you are multiplying minus here, it will become here. If you are multiplying minus here, it will become plus here. That is the reason they were saying a dash is equal to minus of a, or a is equal to minus of a dash, whatever it is. I hope it is clear for you people. Can see one more time. I will say this one. Oh, everything went. We will come to the skew symmetric itself. It is a square matrix where A is equal to Aij is said to be a skew symmetric. Is said to be a skew symmetric means when we will say if A dash is equal to minus A, that is Aj is equal to minus Aij for all possible values of I and j. Now, if we put I is equal to j, we have AI and A. When it is putting AI is equal to J or J equal to A, when the row is equal to the columns, it should be possible. Then it will become therefore 2AI, 2AI will be equal to 0. If you consider transfer this numerator to denominator, automatically it will become 0. Since any denominator 0 by any number should be always a 0 for all AIs. This means all the diagonal elements of a skew matrix must be 0. Hmm. Or also you can see where it is they have given one theorem. We will solve that theorem. For example, the matrix B, we can see minus plus minus plus minus plus is a skew symmetric matrix where B dash is equal to minus of B. Like we have solved like A dash is equal to A minus of A. Now we are going to prove some results of symmetric and a skew symmetric matrices. Okay. Okay. There is one theorem. What they have saying, for any square matrix A with a real number of entries, A plus A dash is a symmetric matrix, and A minus A dash is a skew symmetric matrix. They need to prove that P is equal to A plus A matrix. I will solve here itself. What they are saying is B is equal to know what happened to this. I cannot able to write this page, write in this previous page itself. Theorem number 1 for this symmetric matrix. Yeah, what they have said is prove B is equal to A plus A dash. Okay, we will put dash, we will transpose both of them, or transpose on both sides, or you can say dashing on both sides. This will become B dash is equal to A plus A dash whole dash it will become. So this B dash will be continued, and here it will become A dash plus A dash dash into whole dash. This B dash will remain same, A dash will be same. You know that if you transfer any matrix one time, it will be same. Again, if you transpose one more time, means it will become the similar, the other, the A itself. I will show one more time for you people. This will become A. Okay. And you know that in symmetric, in multiplication of the matrix, A plus B are equal to the B plus A, whatever it is. So, B plus is equal to, you can write this as an A into A plus A dash. Since you will getting the same result, so therefore B is equal to A plus A dash is a symmetric. I will show you 1 minute why it is A and A dash. If you see on 4, 5, it will be 2, 3, 6. Again it is 4, 5, 6. To transpose for one time, we'll write first one is 1, 4, 5. Second is 4, 2, 6. And the third one is 5, 6, 3. I have written in from this order itself. Again, if we transpose once again means A dash dash. Hmm. I think I should consider one, at least 1 or 2, 5, 6 here. Hmm. Minus 5. Again, it should be same. Again, if you consider from here also, let 1, 4, minus 5 is minus, guys. Consider the second column 4, 2, 6. Consider the third column minus 5, 6, 3. See, even though there is no change in this first one and second one, that's why A dash is equal to A. Okay, the transpose of the matrix. Again, A dash into dash will become A. Okay. Hmm. Hmm. I hope you people are getting clear from this. We will now solve the next theorem. Hmm. The second theorem is second in the self. Here it is. C is equal to A minus A dash. Again, we will transposing on both sides. C dash is equal to A minus A dash. C dash will become A dash minus A dash dash whole square. C dash is equal to A dash minus A. Here it won't be like A plus B is equal to B plus A, but A minus B is not equal to B minus A. So for C dash, what they will do, we will take minus common A minus A dash. It is similar to like 4 minus 5. You can take A minus B, I will take. It's better to understand. If you consider A minus B, we will take minus outside and we will write B minus A. Once you will do this, solve this one, minus into B will become minus B, minus into minus will become plus, minus B, this will become A. So you can again, you can rearrange this order. So that's why we will write this in this one. Again, you people know that this will be your minus C. Okay, therefore, C equal to A minus A dash is a skew symmetric matrix. Okay. Okay, these they have written this one transposing on both sides. Okay, so again A dash is equal to A plus 1. This will be the same thing. This A dash will become A. Here it is. The A plus B is equal to B plus A. Again it will become B. Is a symmetric. So now for skew symmetric is equal to image transposing on both sides. A minus A dash, A whole dash, A dash minus A, O minus A. C is equal to A minus A dash is a skew symmetric matrix. Okay. Let us go with theorem 2. This theorem is also simple. We will see check first and I will be explaining later. Okay. Any square matrix, it has written in the theorem 2, any square matrix can be expressed as the sum of a symmetric and a skew symmetric matrix. Proof. They are saying we can express any square matrix can be expressed as the sum of symmetric and a square symmetric. Means we should sum means plus means add. You can add any symmetric and a skew symmetric, so we will get the square matrix. Okay, how it is, let us see here. Let A be a square matrix, then we can write A is equal to half plus A plus A means A plus A dash means a symmetric matrix, and half 1 by 2 A minus A dash is a skew symmetric. From the theorem 1, we know that A plus A dash is a symmetric and A minus A is a skew symmetric. Okay, we have already solved this one. Since for any matrix A, Ka will be equal to Ka dash. Like it is a scalar multiplication. If we have given, if they have given 4A means, we will doing a 4 into that given matrix, scalar matrix. Okay, they are saying that in this thing, you cannot say that see 4 dash into A dash at that time. If they have given 4 into A whole dash means the 4 will remain same and will apply the transpose of the matrix on the only on the given A matrix. Okay, and this will happen. It follows that what is this A matrix? See the constant they have taken 1 by 2. If I take 1 A plus A matrix, the same thing they have taken the constant term. They have taken this constant term 1 plus 2 A plus A dash. Okay, let us see what is in the next paper. is a symmetric matrix and 1 by 2 A minus A dash is a skew symmetric. Okay, same. A minus A dash means skew symmetric. Thus, any square matrix, any square matrix can be expressed as the sum of a symmetric and a skew symmetric matrix. They have given one example. Let us see this example so we can understand that theorem in clearly. Okay, let us start. We can express the matrix B as the sum of symmetric and a skew symmetric. Guys, one thing it should be clear that whenever they are saying symmetric means you should check that A plus A dash. Whenever it is a skew symmetric, it should be A minus A dash. Okay, this should be always hit in your mind how it was there when we are solving the addition and a multiplication of the matrices. Okay, I think it will take 3 to 4 minutes. Okay, um, yeah, we will do this on the next. Uh, let us start. At least we will complete one, and we will do next other one on our next time. Okay. It is example number 22. What they have given? Express b is equal to what is b? 2 minus 1, 1 minus 2, 3, 2 minus 4, 4 minus 3. See here you can see since this is not a symmetric because the non-diagonal elements are same. See the symmetric non-diagonal elements doesn't matter, but when you see non-diagonal elements, here it is minus 1, 1, 2, and if these numbers are not same, so that's why we need to find whether it is a symmetric or not. Okay, for symmetric, this is B, and if you consider B dash, we will write B dash here itself. Start from here, 2 minus 1, 1. For second column minus 2, 3, 2. The third one minus 4, 4, and it is minus 3. Okay. What is the condition for symmetric? For symmetrics, let P is equal to half of B. They have given B. We will take B to B dash. Okay. We will do the in the same manner. 1 plus 2. Do first we will take 2 minus 1, 1 minus 2, 3, 2 minus 4, 4 minus 3 plus we will consider this B dash 2 minus 2 minus 4 minus 1, 3, 4 1, 2 minus 3. You see, I will write one more step for the understanding purpose. It become 2 plus 2 minus 2 plus minus 1. This is minus 4 plus 1. This is minus 1 plus into minus it will become minus 2. This is 3 plus 3 or 4 plus 2. You know that when we are doing the addition of the matrix, corresponding elements must be same. 1 plus into minus minus 4. Here 2 plus 4 and again here minus 3 minus 3. 1 by 2. 2 plus 2 will be 4, minus 2 minus 1 will be a minus 3, minus 4 plus 1 will be a minus 3, minus 1 minus 2 will be a minus 3, 3 plus 3 will be a 6, 4 plus 2 will be a 6, minus 1, 4 will be a minus 3 again it is, 2 plus 4 will be a 6, again minus 3 will be minus 6. Okay, we will do this by 2. Yes. is equal to 4 by 2 will become 2. This will become minus 3 by 2. Again, this will not divisible, so it is minus 3 by 2. This is also minus 3 by 2. 6 by 2 will become 3. 6 by 2 will become 3. I need to write this one again. Again, the minus 3 is not divisible, minus 3 by 2. Again, 6 is like 3. Minus 6 by 2 is a minus 3. See, if you see this is a diagonal element. You cannot change or do anything with this. If you see this non-diagonal elements, minus 3 by 2, minus 3 by 2, same, minus 3 by 2, minus 3 by 2, same, minus 3, 3, this is also same. So, if you are doing the P dash also, you're getting the same thing. You start from here, 2, minus 3 by 2, minus 3 by 2. Again, the second column, minus 3 by 2, 3, 3. Third column, minus 3 by 2, 3, minus 3. So, therefore, it is a symmetric. Is a symmetric matrix. Okay, I hope you people understanding. Okay, guys, we have done till example 22 symmetric matrix. In the next video, we will solve the theorem skew symmetric matrix, and we will start the exercise 3.3. Okay, okay, guys. Um, Now it's a time to wind up the session. Thank you for your patience and everything. Before watching the next video or after completing this video, please try to solve at least one time, so you can never able to do this chapter again till your exams. You know, don't need to worry about the exams here. This chapter carries around some 5 to 6 marks for your examination. Again, it is like a basic for your determinants and other chapters also. Please do this thing. And one more thing, please share with your friends, subscribe to the channel and like the video. We will meet in the next session. Okay, bye guys. This is AK signing off. Bye.